All right, so I'm going to give you guys the other identities that I find useful, which are the double angle identities, which are not so useful, and then the half angle identities, which are more useful later. So first things first, double angle identities, and I found a cool new way to do this. So I'm really excited. So you guys, if you go look at the trig videos, there's a way to come up with sine of 2 theta and cosine of 2 theta from what? You guys remember where you can get these out of the trig videos? Like what was the method we used in trig class?
Sum of angles, you break it apart and use the sum of angles.
Good. You look at sine of 2 theta and you think about that as sine of theta plus theta, right? And then you run the sum of angles identity. Remember the big diagram with the things that came out of that? Cool. So you run that on theta and you get some answer. For the cosine one, you do the exact same thing. You think about it as cosine of theta plus theta, cram this into the identities, you come out with some kind of answer. Cool. But I found a new way to do it. Your textbook does this a different way, so I'm really... So if you want to see that way, trig videos. This other thing is cool though. So this is what we're going to do. So the thing I'm shooting for right now is just sine of 2 theta. So, oh, and I have my ruler. Cool.
I'll laugh if it's still not square.
Oh, that's a pretty solid angle.
Complaining. So much complaining.
No, just doubting.
Just doubting. Okay. So, I have 2 thetas.
You have to complete the line.
Oh my gosh.
It's gonna hurt Dave's brain. Okay, so I have thetas, right? And 90s, and I'm gonna put this in the unit circle. Okay? And I'm looking for sine of 2 theta, which doesn't seem obviously in this picture at all, right? Okay, so let me label some stuff. How long is this particular side over here? That's sine of what now? This one, right here. There today. That's sine of theta, right? Why is that sine of theta? Perfect, because it's opposite of theta in a triangle where the hypotenuse is 1. How long is this other bit down here?
I want to say negative
No, it's still going to be sine.
Yeah, I didn't mark this as minus theta, right? I kind of cheated a little bit. In terms of length, at least, it's sine of theta long.
Yeah.
You guys good with that?
Well, if you just solve for a length, then you can just flip it whichever way you want.
Yeah, exactly. You guys good with that?
Mm-hmm.
Okay. How long is this side here?
Cosine.
That would be cosine of theta long. Cool. All right. I'm going to add to this picture another thing. I'm going to put an angle up here. I'm going to call that angle A for kicks. Now, in terms of angle A, how long is this other side here, this cosine theta side?
That'd be sine.
That would be sine of A, right? You guys with me on that? Okay, so those two are the same one. All right, now,
That means that sine theta is also cosine, right? Cosine
Yeah.
A. Yeah, I said cosine A.
mhm.
I like it.
Yeah, that's also true. I only need this one for the moment. Now, I'm going to talk about this blue angle here, which is how big?
2 theta.
Okay, perfect. That's 2 theta, right? Okay. Now, 2 theta is the thing I want to calculate the sine of, yeah? Okay. What rule do I know that involves sines and deals with triangles?
Law of sines.
Yeah, I know the law of sines, right? Okay, so let me write down the law of sines. So what does the log sine say?
Sine, sine A over A.
Okay, so hang on, I don't have things labeled that. Oh, I do have some things labeled that way. So I have sine of the angle A divided by,
One-sided.
good, should be side A, which is in this triangle 1.
Yeah.
Okay, see that? Okay, so that's information out of the red part. Is,
Sine B.
Sine theta over one.
Theta.
okay, wait, I want to apply it to the whole triangle, right? So the blue angle is the one I'm going to
It's
go
2
for.
theta. Okay.
So I'm going to do sine of
2 theta
2 theta.
over 2 sine.
Yeah, I was gonna say, would it be over sine theta?
Okay, and then it's going to be over, and it's going to be over this whole length, right?
2 sine theta?
Which is twice the sine of regular theta long. You guys all see that? So that's kind of a funny trick, right? Because I'm thinking about this thing is a side length, right? And then this is sine, and this is an angle, right? That's opposite that side length. Same here. Sine of an angle opposite the side length. You guys all good with that? Okay. Now I'm going to do the trick here, which is, what's the trick? What do I know about sine of A?
It equals cosine theta?
Yeah, it's cosine of theta, right? You guys see that? So I can just literally slash this and replace with cosine of theta. I don't really need the over 1 here. And that's sine of 2 theta divided by 2 sine of theta. Guys with me on that? Now what's the thing I was trying to solve for? Sine of 2 theta, right? So what do I need to do to that to solve for sine of 2 theta?
Times everything by 2 sine theta?
Okay, multiply both sides by 2 sine theta. So you'll get sine of 2 theta equals,
Cosine theta times 2 sine theta?
okay, which I'm going to write as 2 sine theta cosine theta, just to be confusing, basically. Cool. So I rearranged a little bit. This is the same thing you would get out of applying the sum of angles identity to theta plus theta.
Cool.
You guys with me on that? Cool. So this is the double angle identity for sine. Check. Okay, let's try to get the other one.
Sorry, how do you get the cosine theta on the left-hand side?
Good. So I got the cosine theta on the left-hand side from this observation. So
So that's.
here's an angle A, right? So in this little triangle, right, this side is opposite of angle A,
I see.
and the hypotenuse is 1, so this is sine of A.
Got it.
But it's also adjacent to theta in a triangle with a hypotenuse of 1, so it's also cosine of A.
I was thinking you were thinking in terms of the big triangle, but I guess it.
Yeah, for that one I'm thinking in the little triangle, and for everything else I'm thinking in the big one.
Got it.
You guys cool with that? So to get these lengths, the sine thetas and cosine theta and the sine of A, I was thinking little triangle. For the rest of it, I'm thinking big triangle. Cool? Question sealed? Okay, so let's run through the cosine one.